All right, good morning. What is up, Liz and Noe? Nice to see both of you in the chat, in the Discord there. Let's see. Like I'm zoomed in more than before, so I had issues with my camera. It seems like the camera that I usually use here for the face cam died on me. Doesn't want to power up anymore. Quick swapped out to a different one, but the settings seems just need to be tweaked for that one. But we are here nonetheless. We're good to go. I'm going to shuffle a few more of these windows around. There we are. Let's go to the browser. Here. This one. All right, so welcome. First of all, what is up? For anyone that's new, if you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I stream around this time each week, 10 a.m. Central Time here on Tuesdays, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. The way it works typically, you plug these devices into your computer with a USB cable. They show up like a thumb drive. You can edit a Python code file on there. When you save it, the microcontroller will execute the Python code for you, and the code itself can interface with whatever other hardware you hook up. So some of these devices are pretty bare bones, like these Raspberry Pi Picos have loads of I/O pins that you can hook up whatever you want. Other devices like this Circuit Playground Express is more purpose-built. This one's aimed at teaching and learning and maker projects. It has a bunch of RGB LEDs, NeoPixels. It has a couple of buttons that you can do whatever you want with. It has a switch, a speaker. It has an accelerometer, a temperature sensor, a microphone, I think. It has IR input and output. So this one has all kinds of stuff to make interesting stuff with, and also just to learn the basics of programming and electronics. And there are loads of other different devices that are built for different purposes. You can find the ones that support CircuitPython listed here on this page, 655 of them. What is up, VP Tech Ops? And over in the YouTube, what's up, Relic IC? Morning, just finished watching the Nintendo Direct. Just time to wash that down with some CircuitPython. Nice, yeah. I don't keep up with Nintendo much, but I imagine there's news in the Switch and game worlds and stuff. I used to work with a friend who was more abreast of the Nintendo stuff than I was, so he was always on top of the new Switches and the new Pokemon releases and that kind of stuff. Let's go to the Adafruit side. As always, CircuitPython is an open source project. It is brought to you by Adafruit. They pay a team of folks, including myself, to work on it. There are contributions from members of the community as well. We very much, cherish the community and the contributions that come from there. But there is a core team of folks who Adafruit pays to work on the project for maintenance and to keep everything moving forward. Adafruit is a hardware and software company based out of New York. They not only fund CircuitPython, but other open source software. So if you would like to help support them and all of the open source software that they support, one of the easiest ways to do it is by purchasing hardware from them at their website, adafruit.com. You can get yourself microcontrollers. You can also get yourself all sorts of bits and bobs and doodads to hook up to your microcontroller to make fun and interesting things with. You can also visit the Learn page if you go to learn.adafruit.com or click the Learn link here, where you will find loads and loads of project guides. These document all of the Adafruit products, as well as document many, many projects that you can make using Adafruit hardware and more. And if anyone here is interested in IoT deployment, edge, sort of embedded Linux type stuff, Ubuntu Core on Raspberry Pi guide just went live earlier today or yesterday, so you can check this out now if you are interested in using Raspberry Pi with this Ubuntu Core OS. This is my latest guide here if anyone wants to check it out. For today's stream, though, I'm jumping into Circup, and basically I'm going to be working on what we talked about a little bit yesterday in the meeting. In the weekly meeting, for anyone who doesn't know, on Mondays, We do the weekly meeting over on Discord, and in the weeds, I discussed a bit with Scott about where to put these Circuit Python runner scripts that I've been working on the last couple of streams. And the consensus that we came to was that Circup would make sense for these things, even though it's not really specifically tied to the libraries and the updating of things. Window here. So that is what I'm going to work on today, is starting this integration. And I think there's kind of two ways we could do this. So in Circup, Circup is a Python click command line interface. So there is a main Circup command, and then there's a bunch of sub commands like Circup install, Circup update, Circup examples. There's a bunch of different ones. Those all go through here. So the two ways that we could do this is we could work on the command layer first, and then we could work on the backend, or we could work on the backend first, and then we could work on the command layer. And I think the backend probably makes the most sense, because that is where the code that I currently have is basically gonna live. And I think what we want is another one of these, what I will call interface functions. Basically, these functions that are defined but not implemented here in the backend base class. So this would be like a superclass or an interface in Java. Def. So let's go run code. This is gonna take a target file. It's not really gonna have a location. It's gonna know the location because the location's basically gonna be code.py. But again, this one is gonna be not actually implemented here. It will be implemented in the backend, the subclasses, so the USB backend and the web backend. So this will be run a specified script on the device. Let's say code file, and return or print. So the backend is going to return. The command line interface is going to print. The backend is going to return. And return I'm going to say serial output, actually. Serial output. Make it clear what that is. None of the rest of these have periods, even though they probably should. So I'm going to make it consistent for now. But we could probably argue for fixing all of them. In fact, why don't we just fix them all? So now these don't have periods either. Okay. Whoops. So then we can now get in. I'm just going to collapse the base class. And then we can get to the disk backend, which is USB backend. And I'll try to keep it more or less in sort of the same order. So I think I put that under copy file up here. Maybe what I should have done. I wonder if there's a shortcut to collapse all the things inside of a thing. Yeah, it was under copy file. Pretty big. Okay, so this will basically just be USB runner. Now we will need, so we're inside the backend, which means we already know the location of the device here. So we don't need to worry about like where the device is at. The backend already knows that. We'll have to worry about it as we filter up to the command line, although it's mostly taken care of by existing arguments. Truthfully, we can just use those. Yeah, so USB, so we basically want a lot of this stuff, but not everything. So we can, we're not doing any more command line stuff. So this is right now written to be a standalone command line script. Duration. Duration is a new thing that we will need to add when we get to the command line layer, which means actually backend is going to need to take duration as well. Let's add that. Target file duration, we will just default it to 20 seconds for now. Oh, this should raise. Forgot that part. So the idea is you would never have a plain one. So if you end up in that situation, then it should raise. Or if you end up with a class that didn't implement it, then you don't have an implementation to use. Okay. This stuff was sort of like here. We will need to import a bunch of things. We'll need to get a bunch of stuff. So serial, we will need to import, and that's actually a, I think that's PySerial, which is a new requirement for Circup. So args.port, that should be available on the backend, which is self. Device location, maybe? Well, actually, this is a bit tricky because we don't have that yet. That is actually one thing we don't have yet, which is the serial port. Circup, as far as I know, does not do anything with serial today. Serial. Huh. Why is that mentioned? Serial. Interesting. I don't know why that would need to be in this list. The rest of these are like related infrastructure type things. But this one, oh. Okay, yeah, nothing else is using serial though. And this is not, this is like a list of things not to include, which not a thing that's actually in use. Okay, so we are going to need, well, we have two choices here actually. We could either say that run code requires the serial port, or we could say that the backend gets the serial port when it gets created. I don't like that one though, because in all the rest of the commands, we don't need the serial port, therefore it shouldn't be required in all those cases. So this should just be on run code. So target file, serial port, that'll be on the base class 2. Target file, serial port. Okay. I think I'm gonna have to go feed the cat real fast. Yes, okay. Yeah, I'm gonna do that. BRB. This will be serial port, baud rate. We can default timeout. They should have a timeout, truthfully, but I'm going to leave it that way for now because it's working. Wait for prompt. So we need that function. Let's finish doing this, though. Path. We do have path. Path is backend location. So self device location. Now, one question is, though, does that have a trailing slash or not? And I do not know. Looks like it's not going to have a trailing slash, at least based on the tests. But we'll see. So then we would also want that. Should probably use pathlib or something. File name, so that is target file. Destination path, follow, yes. Time we need. That is a function we need. That is another function. Duration we will get from here. Okay, so we just need our two functions. Then control, wait for prompt. Actually, is there three? There's three. Read for duration is another one. These could be technically in here. I don't know if it's... Did I not copy three functions? Why do I have three things highlighted? Direct me. Okay, yeah, I see. Here. They're double. Everything else needs to go in a bunch. Well, everything else needed to go in two. And then there's this. One question is, should we be printing here? I'm gonna leave it for now. Although once it's inside click now, most of the other stuff it does click.echo. It may need to be updated to that if we do want it to print. Which I guess I do want it to print because I don't want you to like, if your thing does actually take 20 seconds, then you don't have to wait for 20 seconds before you see the stuff that printed at the beginning. I'd rather it print as it goes. It can also return at the end so that you can... Although in this case, it's not actually returning. I think I changed the web one to return, though. Not this copy of it, actually. Maybe because because I was working in here. Where's Max? Is it on the device? Huh. No, there it is. Okay. Yeah. This one is the web workflow one. And in it, I did actually modify it to return at the end all of the output, which was necessary because when it is being used in this capacity here, like inside of a test for PyTest, the PyTest context needs to get the output so that it can insert against it to make sure that it was matching whatever's expected. Yeah. But I never actually did that to the USB one yet. So we should go ahead and do it. So that actually happens where? Only at the very, very end, and also at the ending early end. And I actually ended up calling it serial output. There's another thing that's called line buffer. I kind of think that line buffer is actually holding the whole thing as well. But I just added this one instead of figuring out if that's true. In any case, line buffer, I think, is the wrong name if it is actually data. Line buffer is not a very good name if it is holding more than one line, which it appears to be because it gets created here and it gets added to and it gets added to. Here it gets... Okay, this is actually the key right here. So line buffer is correct, I think. And we do want serial, so yeah, this is necessary. In fact, I was thinking it might not be, but it totally is. Return serial output, so we return the full thing there. And we also return it here in the early end case, which is unexpected none. Oh. String. I never remember which one is what for how do you declare the types exactly. The Java is too deep in my brain. This one defaults to 10. We should make it consistent. I'm editing the wrong file. It's unfortunate. Okay, we're gonna copy this. Put it here, which is gonna re-rec the tabs. No, because this is WebSocket. We just have to edit this again, basically. Serial, what did I say? Output. Basically copied it to the wrong place. And I can't just copy the whole thing because it's actually different. The rest of it's different because it's web workflow. As the else if serial waiting. Okay. And then here, this time I know that it's string this way because we just did this. Okay. Now we have that actually returning. And this will be helpful because the tests, I think, use this directly instead of Circup. Well, I mean, we'll see, actually. Because it's in Circup and Click, it's actually probably just easy to do it either way, honestly. I think it's easy to do it either way. Okay, so theoretically, run code here should be able to run code on a USB device. So let's save this. Let's go to commands. Let's make a command for run. A long time since I added one of these. We want to do a basic one like uninstall. Because this pretty much just calls uninstall on the back end. Yeah. I'm gonna find one to basically copy from. Any branches? Should change this to rough maybe. Okay, so def. I think it might actually have to be the name that we want it to be for the command. So it's just going to be run in this case because it should be circup run on the command line. Context. And then the arguments. So we're not going to have module. So what? I don't know what in args means. What is that actually? Is that the number of arguments? Don't. Args 1. They're all -1. This is like the only one that has it though. Okay. We're gonna have a target file. We're gonna have host. Well, we're not gonna need. We don't need host yet. We're not doing web workflow. We're doing USB first. But even when we get to it, host and password are already handled. But what we do need is the serial port. So I think we should have one of these. Oh, type. That's what we would want for the target file, surely. Serial port. Should we make a shorthand? I don't even think we should have a shorthand, honestly. Serial port. Specify a code file to run on the device and get results. Serial output. And print serial output from. So typically, really. I mean, it's going to get saved as CodePy, which is typical, but it doesn't matter what it's called on your local machine. Okay. Target file, serial port. So we do need to do some of this stuff. Running to print instead of an echo. Running target file. On device path. Device path. Just say device path space. Well, it's going to be 2 paths though. Just kind of looking. Let's just leave it like that. What else does this do? Name stuff for modules. We don't actually care about any of that. Backend though, that's where we pick back up. Backend run code, was it? Target file serial port, is that right? Target file serial port. Duration we can leave default. Well, we'll pass through duration actually. We should go ahead and add it. This should be Duration. This one can use -d. Unless something else uses. I don't think anything else uses. Type. I click. Is there a click dot? Int. Event. There's int range. So I guess we could say like 1 to a lot. How long to listen to serial output if end is not. If it reads this, then it will stop early. But if it doesn't, then it will go for this amount of duration. So then back in target file, serial port duration equals duration. Duration. Okay. I think that should actually be theoretically enough to do this. Nothing really to see here, and my camera, as noted, got swapped out, so I can't show you the device I'm working with, but I just plugged in a other something, RP2350. Right, so let's try testing this. Circup, run, test code, serial port. Is it? Keyword duration. Core decorators. Huh. None of this came from my code directly. But surely I just declared duration wrong or something? This needs a comma. Otherwise those strings just get concatenated, which is why it was... the dashes got changed to underscores, which I don't know about that, but... that got a little bit farther, I think. It started doing stuff. It printed this. This is coming in as a tuple. So that's probably part of the next problem. Copy file is expecting a string, not a tuple. So I guess target file, because this is click path, by default that must count as a list, seemingly. But I think here what we could do is if is instance target file tuple, then target file equals the first one. Try again. Okay, didn't crash. Oh, it did crash. So one downside to putting these inside of here is we are shadowing the names. Maybe we shouldn't actually have these inside of run code. Maybe these should be out here. In private. Expected type float? Oh. These could be static, I guess. Red still. And control. Oh, we don't have self though. This one can't be static. Well, it could call disk backend, I guess. Disk back. Still have float. We're probably still gonna have float and none problem. The duration here should be a float. Timed out monotonic's definitely a float. I don't understand how this could be none. Oh, because it could get passed as none. Here. But it defaults to 20 here as well. Maybe that should be a float. Mans. I didn't pass it, and it doesn't default. Their default? Nice, there we go. All right, so we got our printout that says we're running this. We got our actual output. Maybe we should say running test code on, let's go to that, running, shoot. There it is, running target file. Maybe, I think what we should do we care about the, yeah, we should keep printing the path. We should keep printing the path. Probably change it. Hopefully it will just print the host by default for web backend. But let's do that, and then let's say print serial port, serial output. So now this is going to say where we copied the file to. And then it's going to say where we read the serial response from. Actually not sure why we got these. Seems like it... Well, I guess because it just kept printing. But I would have thought it would have stopped... whenever it read this. Why did it keep going? The weird thing is it didn't go for a full 20 seconds, so... Is it actually noticing the end marker? Yeah. Something printing? Results? The run code would return, but we're not printing that. Huh. Really weird. Print line.strip. Is this actually checking each line? I mean, it doesn't matter that much at the end of the day if it runs, but I do think these should be cut off ideally. If your code prints this. Because if nothing else, it will save a little bit of context if an actual if an LLM is trying to like use this and get the outputs. But also it's just always going to say the same thing. It doesn't really add anything useful. Huh. That is so weird. If we, does it automatically print anything that's returned? Well, no, because it's not printing the whole thing again. Yeah, that doesn't make sense. I guess it's just because it's not coming back in individual lines. Hmm. Okay. So the deal is that remaining contains multi-line text. Basically, we receive a bunch of lines at once. We print them all. Then we go through and split them and check for the end marker. So what if we just don't print remaining, don't print data, and only print each line? We need to strip it? I think we should just do the full line. If it's got like tabs in it, we should preserve that, or spaces at the beginning or anything. There we go. Now we get our own sort of like, this is what's coming, then we get our output, and then nothing else, and we return. I think is what it should do. Oh dear, what happened? There we go. Ow. Okay. So USB is working. Web backend mostly the same. No, because of the serial port. Right. Right, yeah, because this is the next level. Okay. And about something's gonna have to call the other backend, but that's already done before we get here. So this one is a little bit more weird because it doesn't have a serial port. The only thing it needs is the host, the URL that points to the device, password. It needs the HTTP port, but it already should have that. Yeah. I think in this one, maybe serial port is none because it's like ignored, basically optional / ignored. We want it there because we want it to match the signature, I think. But I think in this implementation, it doesn't get used. Only for the USB one. Okay. One thing we should do, this is hard-coded temp, we should do like get temp directory so it works on Windows and other things. And then we don't need a logger. So this was all using the web backend here. We are going to need these. Oh, we should take it from the one that was updated though. Okay. Need WebSocket. And I just went through this whole thing of like, what's the name of the right library? Socket client. Okay, self, we will make these private again. Static. Okay. I wonder if we're gonna have the same problem here. You know, I don't remember having that problem with web workflow, but we should probably treat it the same, where we don't print here, we don't print here, and instead we print here. Basic For password is on self host, also on self. Probably has the port built in, HTTP port. Wait for prompt, so web prompt. So connect the WebSocket. Wait for the prompt, then copy target file to temp CodePy. We need to change that to look up the temp directory, but I'm not going to do it right this second. Then we're not going to create a logger because the only reason this created a logger was so it could create a backend. We're not going to create a backend because we're already inside a backend. So this is calling upload file. So then we can do self.upload file, temp.codepy, put it in the root, sleep for 3 seconds, send control D, and then read for the duration and return the results. There we go. All right, I think that should work. I am not. Am I set up to test? Is this web workflow? Doesn't show. Two, 3, 3. Okay. So Circup run test code. We're not gonna have a serial port, but instead we're gonna have host, password, none serial. Oh, right, because it was none. Nice. All right, so that works too. We will make this not print none. We'll have it do something else for the web one. Maybe it should just print. I don't know. Maybe we shouldn't bother printing the whole thing. Maybe it should just be here or something. Not sure, but there's room to tweak the way it ends up printing. Maybe we don't want to print it because it has password in it. I don't know. But it is working, which is cool. For most of the way there, it's just like a little bit of cleanup, a little bit of refactor. I do think we should probably revisit the prints and change them into click echoes, because I think most of the rest of this code base uses click echo instead of print. And then the temp directory thing we need to do still, look up the actual temp directory for the system instead of just hard-coding Linux. Hard-coding my Linux also, I don't know if they all use the same or not, but all right. I think that's going to about do it for the day, though. It's about 11 here, so about an hour is usually how long I stream. If you would like some more of this type of content, you can come back on Friday here on the Adafruit channel, 4 p.m. Central Time or 5 p.m. Eastern, 2 p.m. Pacific. I will be back here filling in for Scott on Friday for the deep dive for this week and next week. I will be back here on Tuesday as well. So next Tuesday at 10 a.m. Central Time, same time I was here today. We'll be back streaming some more. And I think that is it for now. As a reminder, Ubuntu Core Guide is live if you want to check that out. And also, thanks to Adafruit, if you would like to help support CircuitPython and the rest of the open source software that they make possible, you can do so by purchasing hardware from them. at the website adafruit.com. I do not know for sure about product pick of the week, but check back into YouTube in a couple hours to see if there is a product pick of the week. If so, then JP will be here streaming, and you will be able to get a wonderful discount on some very cool product. So that's going to do it for now. Thank you, everyone, for watching. So long, farewell, and I will see you next time.